Hello guys, in this video we are doing hyperbolic functions where we have our general form f of x is equal to a over x plus p plus q. Now let's see what does a represent. What does p represent? What does q represent? Let's start with p. P represents the x asymptote, which is given in this form. X is equal to negative p. That would be our x asymptote. Then q represents the y asymptote, which is y is equal to positive q. It's positive q, but if it is negative here, your asymptote will be negative q. Then A determines the shape of the graph. Determines shape of the graph. So our graph, meaning hyperbolic graph, is drawn into we have four quadrants on the Cartesian plane, which has quadrant 1, 2, 3, 4. So positive A, our graph will be taking first and third quadrant. This is for positive A, positive A. Then for negative A, it takes quadrant 2 and quadrant 4. So this is negative A, negative A. To find the y-intercept, you let x is equal to 0, then solve for x, solve for this one, solve for y, then solve for y. This is how we find the y-intercept. To find the x-intercept, you let y is equal to 0, then solve for x. So this is how we find our intercepts, x and y. Then we have domain. Domain is the set of input values, which is the x values. So our domain must not be equal to our asymptote line. As you can see, once our domain is equal to our asymptote line negative p, it becomes a 0. Then it will be a over 0, which is undefined. So our domain is not equal to our asymptote line. So x is not equal to negative p, since we said our asymptote is negative p, where y is an element of real, where x is an element of real numbers. This is how we find our domain. Then for range, it's now y values, which is the set of output values. So y is not equal to our y asymptote, which is positive q, where y is an element of real numbers. Axis of symmetry. This is the point where your asymptote lines meet. So our x asymptote, we say it is negative p. Our y asymptote, which is q. So our axis of symmetry is negative p, q. Those are the coordinates. So on the axis of symmetry, we have two lines. Let me have a rough sketch of a hyperbola. So let's say this one will be our axis of symmetry. We have a line that cuts going that side. That one will be parallel to line y is equal to x. So line y is equal to x. We know properties of parallel lines. The gradient is the same. So this line have a gradient positive 1. All lines that are going following that direction, they have positive gradient. Then we have another line of symmetry which passes through this point. Now this one is parallel to line y is equal to negative x. So y is equal to negative x. Then our gradient will be negative 1. So the only thing that we need to find is the y-intercept, that point C. So equation of axis of symmetry is calculated like this. These are straight lines. So equation of axis of symmetry, y minus y1 is equal to m xe minus x1. So you only substitute here. If the question is asking you with positive gradient, you substitute with positive 1. With a negative gradient, you substitute with negative 1. Now I came up with an example. So let's see how we find our asymptote lines, how to sketch the graph. So for us to find our asymptote lines, xc, remember I said our x asymptote is xc is equal to negative p. So our p is 1, so negative p, it will be negative 1. That's our x asymptote. Then our y asymptote is equal to negative 2. Sometimes you may find it different in other books. The x asymptote is called vertical asymptote. Then y asymptote may be called horizontal asymptote. Why we calling this one vertical? Because it is parallel to y-axis, it's going up. And this one is parallel to x-axis. That's why it is called horizontal asymptote. Now let's see how we find the y-intercept. Y-intercept, we let x is equal to 0. So this is our f of x represents y. So y is equal to 1 over 0 plus 1 minus 2. This is 1 over 1, which is a 1 minus 2 minus 1 is our y-intercept. Then x-intercept, this one we let y is equal to 0. So 0 is equal to 1 over x plus 1 minus 2. Which continues here. So if we take minus 2 to our left hand side, it becomes positive. So we have 2 is equal to 1 over x plus 1 over 1. This is 2. 2 is the same as 2 over 1. Then we cross multiply here. So this is 2 multiplied by x plus 1 is equal to 1. Then we expand and solve for x. This is 2xe plus 2 is equal to 1. So 2xe is minus 1. Therefore, xe is equal to negative half. Now we are sketching the graph, a hyperbolic graph. So in order for you to sketch a hyperbolic graph, you need asymptote lines and intercepts, which is x and y intercept. as well as x and y asymptote. So we calculated our intercepts and we have our asymptote lines. So now let's see how we sketch. Our x asymptote is x is equal to -1. So I'll mark it here. Asymptote line must be drawn in dotted lines. Then you label it x is equal to -1. Then our y asymptote is x is equal to -2. Y is equal to -2, then we label it like that. Then we need to mark the x and y intercept. Our x intercept is -12. -12 is between 0 and -1 here. That's where you can mark -12. Also, our y intercept is y is equal to -1. -1 is between -2 and 0. So it's here. So our graph, it will follow this path. You mustn't touch the asymptote line in your graph. This is our graph. Then you trace it on the opposite quadrant. This is our graph, with our asymptote lines marked and our intercepts x and y labeled. X is equal to -1 with our x asymptote, y asymptote, y is equal to -2. So you need to indicate all those things, as well as labeling your x's, x-axis and y-axis. Domain. Domain is our set of input value. So remember I said x is not equal to our asymptote line, our x asymptote, which is -1, where x is an element of real numbers. This is our domain. If x becomes -1, -1 plus 1 is a 0. Once it becomes 1/0, then it's an undefined function. So that's how we find our domain. Now let's see range. Range is y not equal to our y asymptote, which is -2, where y is an element of real numbers. So that's how we find our domain and range. Let's see our axis of symmetry. Our axis of symmetry is -1, -2. So calculating equation of axis of symmetry with positive gradient. Let's start with positive gradient. So it will be y minus y1 is equal to m x minus x1. So y1 and x1, it's our axis of symmetry. So we have y minus -2. Remember we said we are doing positive gradient, so our gradient is +1, x minus -1. So we have y plus 2 is equal to x plus 1. Therefore our equation will be y is equal to x, this is 1 minus 2, we get -1. This is for positive gradient. Let's see for negative gradient. Y minus y1, m x minus x1. Our axis of symmetry doesn't change, it remains the same. What changes is our gradient, which is the value of m. So we have y minus -2, then -1, x minus minus 1. This will be y plus 2 minus 1 open bracket x plus 1. So y plus 2 is equal to minus x minus 1. So y is equal to minus x minus 1 minus 2, we get minus 3.